Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my YouTube channel where we talk about everything I want to, science and math. And what we're doing today is we are talking about Unit 3, atoms and energy. And there's one thing, I tutor college also. And there's one thing that the college kids often don't understand, and I tutor a lot, and so I was sort of just thinking back through this stuff that we learned, and I thought, I'm going to go ahead and teach this to them, because when they take college chemistry, this might be confusing for them. So, turning your notes here, where it's this part where we were talking about the quantum numbers. And remember how we talked about one of our students, that we could send a letter to him, and out of everybody in the whole world, it would go to him if I wrote the address correctly on it. The same thing with these electrons. They have 4 numbers, and if I put them down correctly, out of all the electrons in the atom, we can know which one I'm talking about. So there are 4 quantum numbers. And we talked about that the first quantum number tells which level it is on, 1 through 7. Everybody remember that? The second quantum number is called the L number, and it tells the shape of the orbital it's in. And if its number is 0, then it means that it's in an S room, which is sphere-shaped. If its number is 1, it is in a P-shaped room, which really looks like a number 8. They say it looks like a dumbbell. I've never seen a dumbbell that looked like that. If its number is 2, it means it has a D-shaped orbital that looks like a fat plus sign or 2 baby pacifiers stuck together. If its second number is a 3, it's in an F-shaped room, which looks kind of fuzzy. So that one's kind of easy because F fuzzy. Everybody understands that pretty good from yesterday, yes? Yeah. Okay. All right, the next number, the third quantum number, isn't it fun? Is the M sub L, and it tells you which one of these is it in. Okay, which one of these rooms is it in? For the S, there's only one, but for the P, there's 3 different ones, and we need a way of differentiating. Are we on the one that's on the x-axis, the y-axis, or are we on the one that's on the z-axis? Okay, so everybody understands so far what I'm talking about? Okay, I'm going to write it over here. And I've got all the markers. Maybe this one will write. Let's see if we can see the board. We can see the board over to there. I won't do past that. All right, so if your second quantum number is 0, it's in an S-shaped room, and its third quantum number, which is M sub L, would it be the number of 0? Because there's only one S shape, and that one is designated 0. Okay, are we okay so far? Okay, here's our next one. If our number is P, if our second number, our L number, I'll put an L by it, so it's S, P, D, and F, 0, 1, 2, 3. Everybody see where I got that from? 1, 2, 3. So if its second number is number 1, meaning it's a P-shaped room, how you tell how it's differentiated is like this. The numbers are -1, 0, 1. Now, I'm not going to go into which one's X, which one's Y, and which one's Z. I just want you to sort of understand the pattern of how these numbers go. And you'll also notice on the periodic table that there are 6, the P block has 6 elements in it, but each orbital holds 2 electrons. So there are 3 P orbitals. 3 P orbitals. Are you following along still? The more we do it, the more clear it'll get. Okay, the next idea is D, there's 5 of them. 5 possibilities for D orbitals. Does everybody imagine that all right? So the D, if The second number is 2. It's a d orbital. The 5d possibilities are -2, -1, 0, 1, 2. Starting to see how it works? So what are my possibilities for F then?
-3, -2, -1, 0, 1, 2, 3.
Y'all are brilliant. Yay, very good. Well done. And then our last one, our fourth number would be either for each one, it's either plus or minus 1/2, depending if it spins clockwise or counterclockwise. Now, somebody was saying, why? Why is it that they all spin one way, and then you get 2 in an orbital, and they spin opposite ways? It goes back to the idea that nature likes balance. And when things spin, in physics, they're more balanced. Have you ever gotten on your bicycle and tried to just sit there and not go? What happens if you don't put your feet down? You fall over. But you start pedaling, you've got a gyroscope going, you have spinning going, and suddenly it's much easier to balance, isn't it? So there is a balance that comes with the spinning. So when the electrons fill the orbitals, they'll first fill it clockwise and then go back as it doubles up, and they'll spin counterclockwise. They don't spin the same way. All right, how do we feel about that? All right? Okay, so the next idea is we're going to learn more about how to write electron configurations. And I'm going to keep taping this. I'm just going to move it to over here. So those of you who are watching, I'm sorry this might make you a little car sick. You might want to shut your eyes because we're about to move. I don't want to make people throw up without meaning to because we're about to move. Well, maybe I might want to make someone throw up. One time my kid had something where he needed to throw up. We were at the pool and I gave him Ickapec to make him throw up. It worked. Do y'all know what Ickapec is? It makes you throw up. So like, you can't always do it, like if someone has poison or whatever, but if it's something that's not going to make it worse with you coming back up, some things are worse if you throw them up. Like if it burns down, it'll burn more going back up again. But some poisons you just need to throw up. And there's this little bottle called Ickapec, and it will make you throw up. And one time one of my kids needed to throw up, and I gave him Ickapec, and it worked just fine. All right, that works all right. Okay, so now, hopefully I didn't make anybody watching throw up. Okay, so everybody's got a pen, and you've got a chart, and you've got a homework, right? Okay, we're going to talk about what you're going to be doing now. This makes really good TV, the fact that I just wander out of the shot, too. I'm back! All right. Okay, so what we're going to do is look at your homework. On your homework, there's basically 4 kinds of problems. The first kind of problem tells you to write the electron configuration. To write an electron configuration is where you're writing 1s2, 2s2, 2p6. I'm going to go over some more how to do that. There's a song, 1s2 and 2s2, and then comes 2p6. Electron configuration, just they're really slick. All right, I think I sang y'all the song before. I'll try to get more words to it. I've forgotten them. All right, so you need to have one of these. And one of the things with honors level kids is a lot of times they are a little bit perfectionist. I don't know if you know this about yourself or other honors kids, but sometimes they're perfectionists. And studies have shown that when it's a new skill, sometimes honors kids do better if it's not permanent, if we can learn it and make it go away. So everybody was supposed to get a napkin. If you didn't get a napkin, listen to me. If you have this kind of pen, you need to make your napkin damp These are damp rub off. If you have the kind like what Austin has, that's a dry erase and you need a dry napkin. So get a napkin real quick if you need it. Once again, great TV. We're getting napkins now. Look, I'll stand so no kids are in the video. Just in case. I don't want to put kids' pictures on YouTube. All right, hurry up. We're going to learn how to do electron configurations, orbital diagrams, and noble gas configurations. These are our 3 kinds of things that will be on our test. So we're going to go over it. Now, if you are watching this and you're a regular, you did not have to know about those numbers I just put on the board, but what I'm doing now, you do have to know. So regular Kim learns this too, what we're doing. It will be on your test also. Honors get some extra stuff that you won't have to do, but you do have to do this. All right, so this is how we do it. I'm going to show you what to do. You're going to do it too. Until then, you're going to be doing this without me. Now, what we're going to be doing is drawing orbital diagrams and writing electron configurations. Eventually, what you're going to do is you and your lab partner are going to practice and you're going to race each other. You're going to use the electrical devices y'all brought. Oh, look, Austin has one. That right there, that is a scientific instrument that has a timer on it. Y'all all brought your timers with you, right? Oh, I see another one. Y'all brought your scientific equipment. You're going to use your timer, and you're going to see who can go faster. And then we might find out of who's like the fastest in class. And if you want to, you can race me. If you can beat me, I'll buy you a candy bar of your choice. Now, in all the decades I've been teaching, I think I've only been beat once. I did have a guy, I had to buy him a Snickers bar. But I think it was only once. Full size, not even fun size. I'll buy you a full-size candy bar if you can beat me. I had somebody challenge me today. They weren't even close. But anyway, you're welcome to try to beat me doing this. Now, let me teach you how to do it so you can aspire to greatness. All right? So let's start with nitrogen. So step 1, you look on the periodic table and you see the atomic number. I want you to write a nitrogen with the number 7 right there. Put a little 7 and an N is step 1. Next, we are going to use the periodic table to write down the electron configuration. I need a pointer. So I'm getting a meter stick here. All right. So how we do this is this way. You start, and the electrons, they fill in the order that the periodic table is going to show us. So the first electron goes into a 1s room. The second electron goes into it's like helium is in this square right here. So the second electron also goes into a 1s room. So what we write on here for our electron configuration is we write 1s, and we have 2 of them. First level, S-shaped room, and we have 2 of them. We go to the first level, and we draw arrows to represent those 2 electrons, one going up and one going down. This is the orbital diagram. This is the electron configuration. Straight to the camera there. So we're working on this and that. Now, you can draw your arrows. Oops. Like this. Usually they don't draw the whole arrowhead. They usually just do a half an arrowhead. Who knows why? I guess because we're lazy. And it just tire us out to draw a whole arrowhead. All right, the next 2 electrons. No. Shh, don't be loud. You'll mess up our great YouTube video. Our next 2 electrons go into the 2s room. So on that, see how this one's sphere-shaped? So the next 2 electrons are going to go right here. First, your arrow, you need to draw your up arrow, then your down arrow. And the next part of our configuration is 2s2. 2s2, write it up here. 2s2. Okay? The next rooms that fill, you just keep going across, is level 2 type of room P, and we're doing nitrogen, and there's 1, 2, 3 electrons that go. So on these ones that look like number 8s, we draw 3 arrows up. 3 arrows up, and our configuration is 2p3. This is our electron configuration. That's our orbital diagram. How do we feel so far? Making a little bit of sense, maybe? Well, let's do another one. Wipe that one off. And let's try again. Wipe it off and let's try again. We don't have to talk about it. Just wipe it off. All right. So let's try a harder one. Let's do chlorine. We're going to do chlorine. So step 1, how many electrons does chlorine have? 17. So we're going to write 17Cl right there. Okay, now I'm going to just show you how they go in, and then I'm going to go back and we'll write it down. Okay, I'm just going to show it to you by pointing right now. How these 17 go in is 1s2, 2s2, 2p6. Then you come back over here, 3s2. This is still in the 3rd level, 3p, 1, 2, 3, 4, 5. Okay, so now let's do it. Let's do the arrows. So the first 2 go here. Oops. 1s2. The next 2 go here. 2s2. The next 3 are going to go here. 2p, 1, 2, 3 up, and then 3 down. 1, 2, 3. The reason why they have to go up then down is up means clockwise, down means counterclockwise. They all get their own room first and spin clockwise before doubling up, and the second electron will spin counterclockwise. And the reason why all this happens is energy. And that's why this unit is called atoms and energy. Okay? So we got the P's. Now we go to level 3, S. We're going to put 2, 1 up and 1 down. And then it's 3p5. So we go 1, 2, 3, 4, 5. 3 up, 2 down. This is the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. P rooms look like the number 8. S rooms look like circles. D rooms look like fat pluses. And F rooms are only on level 4 and 5, and they look like fuzzies. And there's 7 of them. Does the chart make a little bit of sense?
Does it matter which way it's turning, or as long as you have 1 up and 1 down?
You have to do up, 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 and then down, down, down.
It doesn't matter which side the up and down's on?
No,
Okay.
it's on both. Okay, now wait, I'm going to let y'all help each other, but I'm going to do a bigger one now. Okay, and I'm just going to do it by myself. Y'all just see if you can follow along mentally. Try to keep up. All right, so I'm going to do bromine. Bromine is 35. So look up here and pay attention while I do bromine. No, let's not do bromine because I just did chlorine. Let's do germanium, number 32. Okay, so this is the electron configuration for germanium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3. This goes down to 3. If you have, who's got that periodic table I gave you handy? Everybody got it handy? There it is. If you look, get this periodic table out, and if you see right there, it tells you that it changes to 3. As you're going across in straight lines, it changes to 3 right there. 3D. So now I have 3D10, and then I'm back to 4P2. The reason why is look at your chart. Do you see how the S rooms are nicer and bigger? So some of the electrons, and it really has to do with energy, would rather jump up to more levels to get a nice S room than being in one of those little cramped D rooms. So the 4S fills before 3D does. Look at it on your chart. 1, 2, 3, 4. Isn't 4S nicer than 3D? Isn't 4S nicer than 3D? This is the apartment with the hot tub and the marble countertops and the walk-in closet. This one, Formica countertops. No hot tub, regular tub, a shower. All right? Does that make sense to you a little bit? Okay, I want to do a bigger one. I'm going to do lead. Lead, 82. Okay, pay close attention while I do lead. You ready? Look up here, Mason. Look up here. Okay, I'm going to do lead, number 82. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. This one's 3, so this is 4d10, 5p6, 6s2, and this is the tricky part. See this? This is a clue telling me that here I go down here next to 4f14. I go back here to 5. See how it says LU here and LU there? That's my clue to go back here to 5D10. And then I'm to 6, the 6 right here, 6P2. They don't fill in order from bottom to top. They fill in order of nicer rooms. You want me to do that one again and see if you can follow along? I'm going to go slow. I want you to look at this periodic table, how it tells you what comes next. You might want to draw an arrow from right there down to there to kind of help you out there. Okay? So let me do another one over here. How about radon? What do you think about radon? Is that one good, or would you rather do radium? Radon. Okay, radon. This one we have a problem with. What's wrong with radon? It's because we have red dirt here in Georgia, we have clay. That causes radon, from what I understand. I'm no geologist, Mr. Myrick is. It causes radon to seep out of our ground into our houses, and it'll give you lung cancer without ever smoking. So we're supposed to have radon detectors to let us know if radon gets in our house. It's colorless, odorless. You won't know it's there until you've never smoked and suddenly you have lung cancer. So let's do radon, okay? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6. That's kind of hard to say. 7s2, 5F14, 3, 4, 5, 6, D10. Oh, I went too far. Oh, no, I didn't. Need to stop there. 7S2, we're doing radium, right? We're doing radar. Then mark that one off. We should have stopped at 6P6. 6P6. Now, there is another way to fill these not using the periodic table. I think it's much more difficult. Let me get it up here. It's this. This also tells you the order. 1S2, 2S2, 2P6, 3S2, 3P6, 4S2, 3D10, 4P6, 5S2. Do you see that? But this I'm not going to give you. You're going to have to, if you want that on your test to use, because your honors, if you're a regular, I might. But your honors, I'm going to treat you more like you would be treated in college, and I won't give you that little chart. I want you to use the periodic table. Why? Because I'm just mean? No. That might be true, but no. It's because if you get off making the chart and the chart is confusing, you've blown the whole test. You've just failed the whole test. The periodic table is already made for you. You can't do it wrong. It's already there. You just have to know how to use it. So that's why I want you to be able to use the periodic table. Because it's showing you the order of the electrons and the orbitals. Now, I've known two science nerds who, when they started realizing the perfection of this, they got tears in their eyes when they were in high school. And they started realizing that this all reflects the atom. And every bit of this is so true it's math. And it's so complicated. And it's what makes everything in the whole universe works. And it's so fancy. And it's only going to get fancier the more you know about it. That the beauty of it moved them to tears. I've known two people who ended up majoring in chemistry. When they really understood this, they got tears in their eyes. Anybody feeling moved to tears over the beauty of this? You have to realize this isn't something somebody made up. This isn't calculus. This is it. This is in the atoms. This is the pattern of the universe. This is the intricate pattern of the universe. This is quantum physics. And it's intricate. And it's math. And it's geometry. And it's patterns. And it was always there, and we've discovered it. So things are more complicated than they appear on the outside. The more we know about it, the more sort of breathtaking it is. All right, how do we feel about this? Now, there's one other kind of problem. It's the noble gas shortcut. So let's do one of those. Did you have a question, Mason, or was that it?
I get the 1S2 and all that, but I was confused in the arrows.
Okay, so let's do another arrow one, and then we'll do its noble gas shortcut. So wipe your thing off, and let's pick another one. Let's do, how about we do bromine? Bromine. Okay, so we're going to look at bromine. It's number 35. Ooh, why did we pick such a big one? BR35. Okay, everybody wrote BR35? Okay, so now we are going to do the electron configuration first, and from that, the orbital diagram. Since that's the way Mason understands it better, we're going to go that way. Some people like doing it the other way, doing the arrows first, but we're going to do it the way his brain's working, okay? So let's write down the electron configuration for bromine. I'm going to do it, and then I'm going to write it down. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Everybody follow that? So now I'm going to write it down. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, what did I say it was? 5. Okay? So did y'all get that? Okay, now I'm going to fill it in this order. I'm going to go to 1S, first floor. Maybe for the other class, they liked this. They liked writing the floor numbers on the back side of the house. So if that helps you, feel free to write the floor numbers on the back side of the house. Okay, so now I'm going to put in the arrows. I'm going to start with 1S2. And on the first level in the S room, I put arrows up and down. Now I'm going to go to the next one, 2S2. So I'm going to go second floor, S-shaped room, and I'm going to put 2 arrows. Up first, down second. My next one is 2P6. So I'm going to go to the second floor, the rooms that look like a number 8, and I'm going to do 3 arrows up, and then I'm going to go back and do 3 arrows down. Now don't let the fact that the 8 has 2 parts to it throw you. It's not 2 rooms, it's 1 room that's shaped like an 8. It's 1 orbital that's shaped like an 8. Can we follow that? Okay, so now we've made it to 2P6. We go to the next thing that gets filled in is 3S2. So I'm going to hop up to level 3 to the S-shaped room, and I'm going to draw 2 arrows. Then I go to 3P, and I'm going to put 6 in there. 3 up, then 3 down. 1, 2, 3, 4, 5, 6. I've made it to 3P6. My next thing was 4S2. So see how little and cramped those D rooms are? Those get rejected. The electron would rather hop up to this beautiful 4S room than be crammed in that little 3D room. So that's what it does. It hops up. So for 4S, hop up there and draw yourself 2 arrows. Good? Okay, next, what comes next is 3D10. Now it goes back down to here. I draw 5 arrows up, I go back and do 5 arrows down on the 3Ds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ta-da! Now the next thing is 4P5. So I go up here to the 4th floor. Find the rooms that look like 8s, and I draw 3 arrows up and then 2 down, and I've got 4P5. Now I'm going to let you work on this for a little bit. I'm going to stop you later once you kind of understand this a little bit more, and I'm going to teach you something else, and we'll probably do another little video for it. Normally, I know this might be a shock, for your orbital diagrams, you don't have to draw a house. So I'm going to show you how you normally draw them. But I think the house kind of helps people understand why an electron would jump up here instead of going down there. Why it goes in this order. And remember, the reason why is energy. Energy. All right, how do we feel? Okay, so what I want you to do is I want you to work with your lab partner. If your lab partner doesn't understand it, I want you to explain it to them. Sometimes another teenager can explain better than me, because I'll just keep using the science words, and a lot of times y'all do a good job of you picking different words to explain it. One of the kids in my other class said, Miss Blackburn, you kept explaining it, it made no sense. He explained it in 10 minutes. And I was like, great, because now you understand it. I don't care if I explained it or if he explained it. My goal is for you to understand it. Then I want you to time each other and see who's fastest. So if you're going to race, pick 2 that are similar. Do aluminum and silicon. Do potassium and calcium. Don't make one person do lead and the other person do lithium. That's not fair. Okay? So race each other, see who's fastest. And then in a little bit, I'll stop you. We're going to look more at the homework, and I'm going to show you more how to get it from this idea onto your homework page, onto your test. Any more questions before I let you just work with your lab partner for a while? All right, then go ahead. Science is great.